Let's do some problems from section 5.5, which is substitution. So what we're asked for right now, see, this is an indefinite integral. So we just use this symbol because we know there's an association between integration and antiderivatives. We learned about that in the fundamental theorem of calculus. So this is what we're given. We're asked to find most general antiderivative of e to the x times the square root of 1 plus e to the x dx. So what we're going to do is we're going to make a substitution. Now, what you want to do is think about the chain rule for derivatives. Because that's kind of where this is coming from. Okay. So remember the chain rule that applied to a derivative of a composition, and we have a composition here. And notice what's happening. We have an inside function, and the derivative of that inside function is e to the x. So that suggests that we try to make a substitution. U is equal to 1 plus e to the x. And if I do that, taking the differential of both sides, which is very much like taking the derivative of both sides, we have du is equal to e to the x dx. So what happens is this integral becomes that integral. Why is that? Well, 1 plus e to the x, that's u, so I now have the square root of u, but this e to the x dx, that becomes du. Now, of course, the square root of u, that's the same thing as u to the 1/2. Now we use the power rule, so the antiderivative of u to the 1/2 is 2/3 u to the 3/2 plus an arbitrary constant. Don't forget about that. Now we're not done with the problem yet, because remember this original problem was in terms of x. So replace u with 1 plus e to the x. So the result is 2/3 times the quantity 1 plus e to the x, the quantity raised to the 3/2 plus c. Now to check your answer, what you can do is differentiate. Let's do one more. We have the integral of sine of 2x over 1 plus cosine squared of x. So it's inconvenient to have trig functions of different arguments. See how the argument here is x and the argument there is 2x. That's not very convenient. So what we're going to do is we're going to recall one of our trig identities. Sine of 2x is equal to 2 sine x cosine x. So replace sine 2x with 2 sine x cosine x. So now we're going to make a substitution. We're just going to try something. Let u equal cosine x. Well, why does that work? Well, because the derivative of cosine is negative sine. So that's going to, so the sine x dx, that's going to be negative du. That's important. I still have another cosine here, but that's actually u. So what I end up with is this integral. So this integral is better than what we had originally. We're not done yet by any means, but we're in a better situation. So let's move on to the next page. And so this is where we are. What we're going to have to do now is make another substitution. So let's introduce another variable. Let's say w. And the reason this is working is, you see that, again, I have a composition where the derivative of the inside is appearing here in the numerator. So we can let w equal u squared, then dw is 2u du. So this, I can bring this 2 back in, just because it's convenient. So for this problem, so 2u du becomes dw. So the negative sign outside stays outside. So we have now dw over 1 plus w. So you have to recognize this. The antiderivative of this is actually negative ln of the absolute value of 1 plus w. So we're not done yet because remember our original variable was x, right? W is u squared, and then u is cosine. So what we end up with is negative natural log of the quantity 1 plus cosine squared of x plus c. So look at some more of those problems, and then send me an email if you have questions. I can make additional videos if needed.